Okay, so the drug has to diffuse through the lipid. It should have two rules. It have to follow two rules. One is only non-polar molecules are lipid soluble. Non-polar means which do not have charge. So no charge will cross the membrane. Remember, no charge will cross the membrane. Okay. Rule number 2 is most drugs are weak electrolytes. Weak electrolytes meaning their charge, whether they are charged or not, depend on the surrounding pH. Depends on the pH of the surrounding medium. And rule number 3, which you may not follow, which is not necessary actually, is like many drugs are also non-electrolytes. Non-electrolytes means their charge does not depend on medium, and they will cross medium readily in all conditions. For example, ethanol. Ethanol is such a drug which will cross in all such mediums. Okay. Now, for a drug to cross through, as I said, it should be uncharged. The lipid solubility means whether it when it gets dissolved depends on lipid water partition coefficient. This lipid water partition coefficient, just remember the name, no necessary. Actually, see what it is. The drug has to cross, consider this is membrane, drug has to cross from here to here. Okay, so the rate of transport from one side to other side is known as rate of drug transport. It depends on two things. One is diffusivity and solubility. Solubility is drug comes and gets dissolved in the membrane, that is solubility. Diffusivity is through which speed it will travel from one end of the membrane to other end of the membrane. So this diffusivity is same for all the drugs. Hence hence the rate of transport depends mainly on solubility. Solubility depends on lipid water partition coefficient. Next thing, as I said, charge depends on surrounding medium. So this is very important. One thing is no charge crosses the membrane, the other thing is charge depends on surrounding medium. Consider, what do you mean by weak electrolytes? They can be either weak acid or weak base. Weak acid, for a weak acid, what is the definition of acid? Acid is something which will give rise to H+. For example, consider this is the general reaction I am writing. Consider this is acid, Ha is acid. It will give rise to H plus A-, correct, on dissociation, but it can reassociate to form Ha. So if you see, this is the uncharged species, so this is the lipid soluble form. So if the surrounding pH is such that it forms this charged species, the drug cannot be drug will not cross the membrane. Similarly, for acid, what is the definition of acid? Acid is something which will accept H plus to form BH, correct? So see here, BH plus is charged here. So this is the uncharged species. Okay, now this thing, whether it will be in charged form or uncharged form, whether it will be in charged form or uncharged form depends on this dissociation constant, both for acidic as well as basic drug. What is this dissociation constant? You will understand once you will understand Henderson Hasselbalch equation. Please remember, on this slide, do not take anything. Do not write down anything. Do not try to remember anything. Just focus on whatever I am doing on screen and just understand whatever I am doing. Okay. So Henderson Hasselbalch equation is pKa minus pH is equal to log of protonated form divided by unprotonated form. We are defining pKa by this Henderson Hasselbalch equation. I will give you example now. Consider all drugs will be having their own pKa. Consider this, there is one acidic drug. For example, aspirin is having a pKa of 3.5. I am taking some drug which is having a pKa of 5. So what will be reaction? Ha, consider Ha will be the acid, it will give rise to H plus and A minus. See, which is uncharged? This is uncharged species. Is it protonated or unprotonated? This is protonated. So Ha is the protonated form and this is the unionized form. So this is in case of acidic drugs, correct? Okay. Now we will see what happens with changes in surrounding pH. Consider the surrounding medium's pH is 5. Okay. What will be this thing? pKa minus pH. What will be this thing? pKa minus pH. 5 minus 5, 0. What log will be 0? Log of 1 will be 0. And for this one, what should be this ratio? What should be this ratio? This ratio should be 50% by 50%. Okay. So it will be log 1 will be 0. Okay. Now at pH 5 with for a pKa drug 5, what is there? 50%. What do you get from this? That is 50% is this, 50% is this, so 50% is unionized, correct? Okay. Now we will see if the surrounding medium pH is 1 less. Just understand. If you don't understand, don't worry, you will understand in next slide. Just listen whatever I am saying. Okay. If the pH of surrounding medium is 4, so what will be the pK minus pH? 5 minus 4, 1, correct? Now log of what will be 1? Log of 10 is 1. Okay. For this 10, what should be this ratio? Approximately 90% divided by 10%. Correct. So what is 90% now? 90% is this unionized form, correct? 90% by 10%, 90% is this unionized form. So 90% is unionized. See what is happening. If I decrease pH from 5 to 4, the degree of unionization changed from 50 to 90%. So how much it changed? It changed a lot. Just change in one pH changed the ionization a lot. So this has been asked as a MCQ. Small change in pH will affect degree of ionization. Yes, it is true. Now let's see what will happen further if you decrease pH. Okay, see 3, it will come again. This is mass, no need to worry. 99% will be unionized. So as the pH is decreasing, degree of unionization is increasing. Unionization means this is having no charge. No charge means lipid soluble. Lipid soluble, correct? Okay. Now we'll see what will happen if we increase the pH. So consider surrounding pH is 6. What will happen? 5 minus 6 minus 1. Whose log is minus 1? Log of 1 by 10 is minus 1. And 1 by 10 means how this ratio should be? If it is 10% by 90%, it will become 1 by 10. So 10% is unionized, correct? Okay, 10% is unionized. Now again, if you increase one more, the degree of ionization will be unionized will be 1%. Okay. See what has happened. As you for acidic drug, as you have decreased the pH or as the medium has become more acidic, the more soluble lipid soluble drug is going to be formed. Okay. Next we will see for basic drug. What will happen for basic drug? Consider again this is a weak basic drug with a pK of 5. Same thing. So what will be the reaction? Reaction will be B plus plus H plus. Base means it will accept hydrogen, so it will form BH plus. See which is charged, which is having no charge. What is important? No charge is important. No charge means it will be crossing the membrane. So in case of basic drugs, what has happened? So in case of basic drugs, which is uncharged, B plus. This is protonated or unprotonated? Unprotonated. Okay, this is B unprotonated form. This is unionized. Okay, so this above one will be BH plus, which will be protonated form will be ionized. So what is important for us? Important for us is unionized form. Okay, we will see again the same thing at pH 5. pK minus pH will be 0. And 50% will be unionized. No change in this. What will happen if we decrease the pH by 1? If the pH is 4, if the pH is 4, the same mathematics will come till here, but 90% is this one, 10% is this one. This is unionized. Okay. So only 10% is unionized. Hope this is very clear. No misunderstand. Please don't misunderstand anything here. Okay. This is concept which you require for later understanding of subject. Again, if you decrease pH by one more, similar same mass, 1% will be unionized. So what is happening in basic drug? In case of basic drug, if you are making the surrounding pH, decreasing the surrounding pH, degree of lipid solubility is decreasing. Okay, so less the lipid soluble will be available. Similarly, opposite thing, if you increase the pH, what happens? Log of 6 minus 1, same mathematics, this will be 10% by 90%. Now 90% is unionized. Unionized means 90% will cross. Okay, so no need to worry if you have not understood anything, just see now. Okay, for acidic drug, understand, as the surrounding medium's pH is decreasing, the degree of unionization is increasing. Means the more drug will be lipid soluble. For a basic drug, if you increase the pH, degree of lipid solubility will increase. And what is pK of the drug? pK is that pH at which 50% of drug will be ionized or unionized, whatever you want to say. So what has been asked? This has been asked. pK is pH at which 50% of drug will be ionized. This is asked for acidic drug. As the surrounding pH decreases, what will happen? Degree of unionization increases and more lipid soluble drug will be available. Or for basic drugs, as the pH increases, as the pH becomes more alkaline, more drug will be unionized, more drug will cross the membrane. Or in other terms, simply remember this dictum: acidic drugs will cross in acidic medium. Finished. Basic drugs cross in basic medium, means basic drug will be unionized in basic medium. Okay, hope this is very clear and there is no confusion in this. Because questions have been asked, which are acidic drug, which are basic drug, you need to remember a few. This is the list of acidic drug, no need to remember by a mnemonic. And this is the list of basic drug. I will say how you will remember. See, for acidic drug means there should be somewhere acid. This is phenobarbituric acid. Okay, this is phenobarbituric acid. This aspirin is salicylic acid. You can say NSAID acid is there in salicylic acid and NSAID. You can remember, or you can simply say probenecid is acid. And also please remember methotrexate. So these are the three which have been previously asked. And also you will remember whole list, because I have made a mnemonic for plasma protein binding. These acidic drugs will bind to albumin, correct? Albumin is a basic protein. The acidic drugs will bind to albumin. So I have made a mnemonic for plasma protein binding of drugs to albumin. The same mnemonic can be used here for acidic drugs. Basic drugs. These basic drugs will bind to alpha 1 acid glycoprotein, which is acidic plasma protein. Again, I have made mnemonic here in plasma protein binding class. You can remember by that. Just I want to say, if you see here, basic drugs are one which either have amine in their name, imipramine, amphetamine, dopamine, histamine, or it will be like for amipyramine, or it will be atropine, chlorpromazine, ergometrin, morphine, noradrenaline. And one more thing is, in source of drug, drugs will be derived from various sources. For example, animal, plant, microbes, etc. In plant sources, the chemical nature of the drug can be alkaloid or oil or any other thing. In alkaloids, these are the alkaloid, meaning these are nitrogenous bases. These are also basic drugs. So you can remember, if you remember, alkaloid agents derived from plants also. They are also same thing. Like atropine is derived from Atropa belladonna. Morphine, opium is also derived from plant. Ergotama, ergometrin and ergot alkaloids are also derived from plant.